Hi, today we will see analysis of quicksort. In our previous video lecture only we have seen the working of quicksort and its partition method. Now let us analyze quicksort. Quicksort basically chooses some random or initial element as pivot element. That pivot element is placed in its correct location, and towards the left of it all the elements which are lesser than pivot will come, and towards the right of it all the elements which are greater than pivot will come. So it would ultimately generate two sublists, one is left sublist and another one is right sublist, which are solved recursively by quicksort. Now quicksort always it generates always unbalanced partition, because you never know where the partition or where the pivot element will be placed. So after sorting, it might happen pivot element is an average element which might appear in the middle, or it is the largest element which is going in the back, or it is the least element which is remaining towards the starting of array. So you never know how much partition of each size will be generated. It generates unbalanced partition. So partitions are unbalanced. That's why we need to analyze quicksort in its different cases. Let us talk about worst case. The worst case of quicksort is when array is already sorted. Irrespective of array is already sorted in ascending order or in descending order, whatever the order array is sorted, quicksort will take maximum steps to sort it. How? Let us understand. So when list is already sorted in ascending order, the first element which is chosen as pivot will remain in its place. The left subarray will never be get generated and right subarray will be of n-1 size. And this process will be repeated for each and every element. So there are n steps will be carried out. And if it is sorted in descending order, what will happen? The very first element, which is the pivot element, which is the largest, after sorting it will go to the back. So if it going to the back side, only left subarray will get generated and no right subarray will be generated. So in this way it will keep on repeating for each and every element, and we only have left subarray and no right subarray. So let us have a look at if this is the array and pivot element is already sorted in its correct place. The remaining n-1 elements will be unsorted, which are towards the right. So n elements, 0 elements towards the left and n-1 elements towards the right. Now after sorting n-1 elements, to the left of pivot there would be nothing, and towards the right there would be n-2 elements. Now to sort n-2 elements, if pivot is sorted towards the left, there would be no elements which need to be sorted, and left subarray will contain n-3 elements. And this will keep on repeating unless and until our left subarray contains only one element which is directly sorted by itself and no more steps will be done. Now can you calculate how many levels are generated? So number of level, first level there are n elements, at second level there are n-1 elements, at third level there are n-2 elements, and likewise at last level total how many steps are there? N plus n plus n-1 plus n-2 plus n-3 up to 1. Only these much steps are performed to generate quicksort. So n plus n-1 plus n-2 up to n-3 plus 2, 1. So this is equal to 1 plus 2 plus 3 up to n. So this is nothing but a summation of I series from I1 to n, which is also expanded as n into n plus 1 by 2. It is also written as 1 by 2 into n square plus n, and this is the simplest polynomial form. So we directly write the complexity of quicksort as big O of n square. Now let us see best case of quicksort. When partitions are evenly balanced, that means whatever the pivot value we have chosen will always placed in such a way that left and right subarray will have almost equal number of elements. So in this case there are two possibilities. There are odd number of elements. So if odd numbers of elements are there, the pivot element is the right in the middle of partitioning. So towards the left and towards the right, there will be total even number of elements. So total elements towards the left and right would be n minus 1 by 2. Remember, there are total n elements. So one pivot is sorted. The remaining elements are n minus 1. And both of these sides are balanced. That means n minus 1 by 2 elements are towards the left and n minus 1 by 2 elements towards the right. So let us understand, in this case there are total odd elements, 7 elements are there and pivot is placed in the middle. So towards the left there are 3 and towards the right there are 3. So in total there are 6 elements which are needed to be solved. So from 7, 3 is n minus 1 by 2 and this 3 is also n minus 1 by 2. Now consider if a sub-array is having even number of elements. That means there are 5, 6 or 8 elements, say for example, and one element is sorted. So remaining elements will be now even, that is n minus 1 elements. So how many will go towards the left and how many will in the right? That we have to understand. So there are total 6 elements and one pivot is sorted. Now pivot is sorted, so there are n minus 1 elements. Towards the left there would be n by 2, that is out of 6 there are 3 towards the left, and remaining elements are n by 2 minus 1, that is equal to 3 minus 1, that is equal to 2. So in either case each partition has maximum elements is n by 2. So we will go with this case. There are n elements, maximum elements towards the left and towards the right are n by 2 only. Now if this process is getting repeated every time, n by 2 elements, there are n by 4 towards the left and towards the right at the max. Similarly for right side, n by 4 is next, will generate n by 8 and n by 8 partition, and this process will keep on repeating itself unless and until each left and right subpartition will have at least one element in its left and right. So there are how many 1 element sublist will be generated? So of course there are total n elements. So how many sublist each of size n will be generated? N. And how many levels are there? At first root level there are n steps. At second level n by 2 plus n by 2, that is 2n by 2, which is again equal to n steps. At third step 4n by 4 is equals to n, that steps will be there. Then 8n by 8, that is again n steps. So how many levels will be generated? N steps are executed, but how many times? So the level, when we divide a node always into 2 and then again any parent into 2, that is complete binary tree, the height will be log of n to the base 2. So total n plus n plus n plus n, how many times? Log of n to the base 2 times. So the complexity of quicksort in best case is n log n to the base 2. Now let us see what is an average case of quicksort. Quicksort average case, the partitions are neither unbalanced nor completely balanced. That means worst case, one partition was not created and another was containing all the remaining elements. In a best case, both partitions are having equal number of elements. So here partitions are created but not so unbalanced or not so balanced. So some ratio is there between left and right partition. So let us consider left and right partition ratio is 1:3. Whatever the number of elements towards the left is there, 3 multiplied by those number of elements will be over the right. Now why the ratio 1:3 is taken? Reason is nothing. You can choose any ratio at this stage and work out and see how complexity will be the same irrespective of the value of ratio you have taken. So some value is to be taken, that's why I have taken 1 to 3 ratio. You can directly choose 4 to 1 ratio or 6 to 5 ratio, whatever you want. But it won't affect our complexity if we work out in a same pattern. So let us see, this is the 5 element list where pivot is placed in such a way that towards the left there is only one element and towards the right there are 3 elements. So we say this is having 1:3 ratio. Okay, now let us see. N elements towards the left, there are n by 4. That means only one element is there. And towards the right, there are 3 elements. So 3 elements out of 4 is there. Now, out of n by 4, towards the left, n by 16 elements are there. And towards the right, 3n by 16 elements are there. Similarly, for 3n by 4, towards the left, 3n by 16 elements are there, and towards the right 9n by 16 elements are there. And we keep on dividing this list unless and until we get one element in its place. Now remember, here division are unequal. That means they are not equal n by 2, n by 2. They are unequal, n by 4 and 3n by 4. So we will get a single node or single value, value 1 at different levels. But the last level where we get only one number or one element is at least element or the last level of our tree. Now let us see how many levels are generated. The very first level where we get a single separated value or an element is log of n to the base 4, because the least left branch is always dividing it divide by 4, 4, 4, 4, 4. So it would be first divide by 4, then it would be divide by 16, then it would be divide by 64 and keep on and unless and until it will become 1. So the level where we first get first element separated is log of n to the base 4. And the longest height of tree where we get the last one element sorted is log of n and to the base 4 by 3. So here we take the largest level, that is log of n to the base 4 by 3. We know that log of n to some base a can be rewritten as log of n to the base b and log of a to the base b. So we will separate out log of n to the base 2 divided by log of 4 by 3 to the base 2, and whole term is multiplied with n. So we know that log of 4 by 3 to the base 2 is some numeric or constant value. So instead of writing a complete term, let me substitute constant c. C into n log of n to the base 2. Now if you have at this stage you have to understand that if I would have taken some other ratio, say 5:6 or 2:7, then only this value or constant value is going to get changed. The unchanged value or unchanged term will be n log n. So constant can be different value, but the term c into n log n will be as it is. So in this case, our complexity of quicksort in an average case would be n log n to the base 2. Let me summarize the quicksort complexity for you. In a worst case, it is n square. In a best case, it is n log n to the base 2. And in an average case also, it is n into log of n to the base 2. Thank you everyone for watching this video. This is Munira Topia signing out.